Yeah, it's recording now. Okay. So good afternoon, everybody. So what I'm saying here is, last time I started to explain a problem, okay? And this problem, we are going to solve this problem using what we call relay. So let me tell you what is the problem. The problem is we have a microcontroller, guys, and we have a motor, for example. This motor needs 110 volt AC, for example, okay? It needs a lot of current, okay? For sure, how, so the problem is that, or the question is, how the microcontroller can control this motor, turn it on, turn it off. That's what I mean by control. Okay, how? For sure I cannot directly connect it directly this way. For sure I can't. You know why? Simply because microcontroller, the output of the microcontroller should be 0 volt or 5 volt DC, but this motor needs 110 volt AC. Okay, this is one problem. There is another problem. The output current here from the output current of the microcontroller, usually it is a small current. It is different from one microcontroller to another, but for sure it's not enough to run a motor. So it's usually it is a small amount of current. So now the question is that how microcontroller can control the motor in this case. Actually, what we do in the middle here, as you see here in the middle, we put what we call relay. So, and in our board, in our Dragon board, we have a relay. So let me explain what is relay. As you see here in this picture, as I said last time, this is the relay is here. The relay has a coil, what we call a coil, okay? As you see here, this coil can be connected to microcontroller, okay? And inside the relay, there is, as you see here, mechanical switch, okay? Sometimes it's not mechanical, but anyway, a switch, okay? So, and then this is, as you see here, this is the motor here, and then this is 110 volt, okay? So if you wanna run the motor, all what you have to do, you have to output one here, as we see here, okay? Let me use another color. Oops. Oops. Okay, let me run it, do it again. Okay. Okay. Okay, so what I'm saying, guys, if you hear your output 5 volt or logic 1, you actually energize the coil here, okay? And once you energize the coil, the coil actually turns into magnet. So it becomes like a magnet. And because it's a magnet, so the magnet is gonna pull the switch, is gonna close so the switch is gonna be closed this way, okay? When the switch is closed, and then so the motor you close the circuit so that the motor can work, okay? This is how the microcontroller can control the motor. Now if you put here 0 volt, if you put here 0 volt, so actually there is no current here, no current, okay? So the coil is not a magnet, and in this case the switch should open, because actually the switch has a spring here, is gonna open, okay? So the circuit now it's open, the motor is not gonna work, okay? So you can see here, guys, as I said last time, if you look at this side, in this side here, in this side, it's a small voltage and it is DC. If you look at this side here, it is high voltage and it is AC. And more importantly is there is no electrical connection between the two circuits, because here there are air here, it's air or vacuum, okay? So that means there is no electrical connection between them, okay? So this is the idea. Now in our board we have a relay, okay? So in this relay we have also, I want to tell you, we have here so just give me 1 second. we actually, if you look at the relay, this is what's inside the relay, okay? Something like that, guys, okay? So, okay, let me, so here, from here to here, this one, we call it normally connect, okay? Sorry, normally open, because normally, as you see, this connection, these two connections, normally they are open, okay? And this is, normally here means when you don't energize the coil, it's open. And once you energize the coil, so you close it, okay? So that's what we mean by normally open. There is another term we use, it's called normally closed. So here, if you look at this switch, if you look at this part here, this switch is normally closed, okay? And once you energize the coil, it opens, okay? So the conclusion, guys, is that inside the relay, or when you use a relay, we have two types of switches. One is switch, we call it normally open. One is switch is called normally closed, okay? Normally means when the coil is not energized, so the switch is open. This is the normal, and here the switch is closed, okay? And once you energize it, so the open is going to be closed, and the closed are going to be open, okay? Sometimes it depends on the circuit, it depends on what you want to do, it depends on your application. So in some application we need normally open, some application we need normally closed, okay? So there is, I almost finished now what is the relay, why it is useful, okay? Now I'm going to talk about programming. Okay, it looks okay. How can we program it? Very trivial, very easy, okay? The way you have to program it, it's just one pin, and then the coil is connected here. That's it, okay? And this is the, oops, and this is here, okay, guys? So it's just one pin. All what you have to do, as we did many times before, you have to configure this pin output, this number one. Number two, you have to output one. If you wanna energize the coil, you have to output zero if you don't want to energize the coil. Very easy. We have done this many times. Just one pin. This pin you wanna output one or zero. Is that okay? But there is a very little problem here. Okay, very little problem. It's not in programming. It's mainly in electronics or circuit. And I want you to know it. Okay, what is the problem? The problem sometimes is the following, guys. For example, here I'm just giving you some numbers just to explain the idea, to explain the problem, okay? Just numbers. This number may not be accurate, okay? Because it's different from one microcontroller to another, but I want to explain the problem or the idea. Sometimes this coil needs, for example, 200 milliampere, for example, okay? And maximum output I can get from here 100 milliampere. That means I cannot connect it directly this way. You understand what I'm saying? So that's a problem. So maximum here, I cannot get more than 100 milliampere, but this coil needs 200 milliampere. So what should I do in this case? Okay, what I have to do is, sorry. What I have to do in this case, we connect here a circuit. We put here a circuit. This circuit, we call it a buffer, or sometimes we call it a driver, okay? So okay, what this circuit is gonna do, this circuit is gonna take a small current from microcontroller and it's gonna give big higher current to the relay. So the way, usually this buffer, it's just a transistor. So for example, I can use a transistor this way, guys, and oops. And actually, oops, the coil, and then the coil is here. You put the coil here, okay? So what happens here, guys, you know the base current is a small current. So if I output here 5 volt, okay? So the transistor is on, transistor is short circuit is on, and we are gonna get a small current from here, and then you know the collector current is much bigger than the base current, okay? So that's exactly what you are gonna see right now, okay? So yeah, so here you understand what I'm saying here, guys? Any questions? So sometimes we use what we call a buffer or driver. Driver or buffer is used, okay, in a problem like this, okay? We cannot get more than 100 milliampere from the microcontroller. We have a coil here that needs 200, okay? So I'm gonna connect a circuit here. Usually it's like a transistor. When I output 5 volt, you are gonna energize the coil, and the collector current usually it's equal beta I base, or beta maybe 100, 200, so 200 times. So here I'm gonna take a small current from the microcontroller, then I'm gonna give a big current to the relay. Okay. And for sure, if you output 0 volt here, the transistor is on. So if you output 0 volt, the transistor is on, and the coil is not energized. Okay. So let me show you in the slides here. Okay. So here, guys. Okay, as you see here, guys, this is the relay I told you on the board. It's here, and you have connections here for normally open. Normally, that's what I told you guys. From here to here, it is normally closed because you can see it is closed. From here to here, it's normally open. Okay, and then when you energize the coil, you actually connect this. This one is not connected. You connect here. So what was closed are gonna become open. What is open is gonna become closed. Okay, that's what I explained. Also, I explained here, guys, how you connect a transistor so that you can take a small current from the microcontroller and give a big current to the relay here. Okay, and one more thing, I want you to learn it. Usually, we put a diode here. The purpose of this diode is. Just give me 1 second. Yeah, okay. So let me go back. Yeah, so this diode here, guys, is used just for protection. This one, okay? That is because when this coil should store energy, okay? So when you turn on the transistor, okay, this coil has to discharge. It's gonna discharge this way in this diode. So it is protection. So that I want this coil to find a base to discharge the storage energy. If you don't put this one, maybe this coil is gonna discharge in the transistor, okay, and it's gonna burn it out. Okay, anyway. So now let's come to program. How can you program it? That's what I said, guys. It's just one pin. It's PET2. It's PE2, okay? And here I explain how can you do it. It's just very easy. Maybe I'm not gonna spend too much time on it. So you can see just one pin. So number one, you have to configure this pin as output, as I said. Number two, if you wanna energize the coil, all what you have to do is you have to just bit set. Okay, you have to output 1 on the pin. If you want to de-energize the coil, you have to output 0. That's it. Okay. Any question, guys? Okay. Topic here in this chapter.
Yes, I have a quick question.
Yeah, sure.
So for the relay, what is the I saw you can't do any AC appliance on the relay because it is a small relay. Do you know what the maximum, like would a 12-volt appliance be able to run off of that relay?
It depends on the relay. Okay, so this is the specification of the relay. So when you buy, that's a very good question. When you buy a relay, the relay is going to tell you what is the maximum current, it's going to tell you what is the maximum voltage, and so on.
Do you know what the maximum of the relay that we have on our board is?
No, really I didn't use it, and
Okay.
I don't recommend using the relay for EC. Okay, because of the safety issues. If you want to use it like, because you can use the relay if you have like 20, if you have a large DC voltage, it doesn't need to be 110. So I discourage students to use 110 voltage just for safety. You got what I'm saying? But what I can tell you, I don't know this relay, but you can, if you can get the number, there is a number on the relay, and you can search online. You can see the data sheet of this relay, and from the data sheet you can get all the information you need. You understand what I'm saying? So what I'm
Yes, I
saying,
understand.
guys, I just give an example. I said if I have an EC voltage, but that doesn't mean I have to use a relay all the time for for EC. It's not like that. For example, what I'm saying, I told you here we cannot output more than 5 volts. Okay? For example, if I have a motor and this motor needs 12 volts, for example, okay? So in this case, still you can use a relay, and this is the 12 volt is here, and here you can connect it to a switch, and still you can use a relay here. You understand what I'm saying?
So you can do that with a 12-volt.
Yes, yes, why not? It's like you just, because this is a separate circuit. You got what I'm saying? So
Right.
yes,
Well, I know that. I'm just saying for this relay,
yeah, I think okay, yeah, I think 12
as
volt
long
is
as it's not too draws too much current.
yes, yes.
Okay.
But if you need the exact voltage, exact current, there is a number on the relay. Take this number, okay, and you can find the data sheet online. Okay,
Okay. All right. Thank you.
thanks. So now let me move to the last topic here, guys. The last topic I want to teach is called binary to decimal conversion and decimal binary conversion. Okay. So I'm gonna explain what do you mean by binary to decimal, what do you mean by decimal to binary. Also, I'm gonna explain how can you do it. Okay. Let me explain the problem first. Why you need conversion? It looks like you are doing conversion. Yes, I'm doing conversion. So why you need conversions? I'm gonna explain the problem right now. Okay, guys. Look here, guys. If I have, if I wanna write a very simple program, I wanna add two numbers. Okay, if I want to add two numbers and I want to get the number from the user, I want to get the numbers from the user. Okay, so I'm gonna tell the user, please give me two numbers. Is that okay, guys? So what's gonna happen is you are gonna use the keypad. So if you use the keypad, as I explained before, okay, the user is gonna hit, for example, just an example, is gonna hit number 2. So what you are gonna receive 32. Okay, because the user hit 2. Okay, and then the user hit number 2 again. So sorry, number 5. So you're gonna get 35. Okay, guys, and then the user hit 5 again. So you're gonna get 35. So this is the number. This is how we are gonna get a number from the keypad. This is what the keypad is gonna give you. Okay, so what should be this number? This number has to be 255. So the user, you ask it, the user give you a number. The user give you 255. But the way you are going to receive this 255 is the ASCII of 2, the ASCII of 5, the ASCII of 5. Because every ASCII here is a key stroke. Is that okay, guys? So that's what we call, this is decimal. This is decimal. Okay, for sure, if you have to convert this number to binary, so here, this is what the microcontroller is going to receive. So the microcontroller is going to receive 32, 35, 35. That okay? That's what I'm explaining now, okay? And then, in order to use this number in computations, after microcontroller has to convert this decimal number to binary, to become a binary number like 1111111. So this is the first number. You understand what I'm saying, guys? So by this way, I have number, and then I can ask the user to give me a second number. So I have to convert also to binary, and then I can do the addition on binary. Okay, guys. So now what I'm saying here, or what I want to explain here, how can we do the conversion here? How can we convert the decimal to binary? Okay. Any question, guys? So let me explain the problem again. We need to convert decimal to binary and binary to decimal. Why? This is because microcontroller can only understand binary, okay? But human are gonna give you the number in decimal, so you need to convert. So if you ask the key user to give you a number, it's gonna give you 32, 35, 35, okay? And then from 32, 35, 35, you have to convert it to binary, so decimal to binary, okay? We also need to do the opposite. So microcontroller, for example, added the number. So I got two numbers from the user, I converted them to binary, and I added them together. And this number, for example, 1111, any number, for example, 1111. Okay. So this number, I have this number for sure. I'm not gonna display to the user this way because human use this. Hello guys, do you hear me?
Yeah, I can hear you.
Guys. Okay, sorry. Because the mic was not working, so I thought you are not hearing me. So great. So you are hearing me all the time, right?
Yes.
Okay. Okay, great, guys. So what I was saying is, so now microcontroller is going to give you the number this way. 1 it's a binary, right? Because this is the language microcontroller is using, binary. Okay. In order to display this number on the LCD, I have to convert this number to decimal, right? So this number has to convert it to 255, and then okay, every decimal number here, I have to convert it to ASCII, 32, 35, 35. And then I have to send this ASCII to the LCD. Is that okay? So that's what I'm, first of all, what I explain here, guys, what I want you to understand is, the last topic I'm going to explain in this chapter is how to convert binary to decimal, decimal to binary, okay? I'm going to explain how, but before I explain you how, I'm explaining why we need conversion. You understand what I'm saying? So anybody here is confused why we need conversion and what I mean by conversion, okay? What I mean by conversion is the keypad is going to give you 32, 35, 35, okay? When you type 255, is that okay? So you need to convert this number to binary so that the microcontroller can use this number in something, in certain operation, addition, subtraction, multiplication. So in order to understand this number, that's what I'm going to explain. How can you do the conversion, this kind of conversion? Okay. Here also we need to do the opposite. Microcontroller is going to give you the number in binary, but in order to display to the user. So if you have this number, how can you get 255 from this number? That's what we call binary to decimal conversion. So you have to write a program. So you have to write a program to take this binary and give you these decimal numbers. And for sure, if you have decimal numbers, that's easy. You can convert it to hexadecimal. From decimal number to hexadecimal to ASCII code, sorry, is very easy. Just you add 30, right? So you add 30 for any number from 0 to 9. All what you have to do, convert a number, a decimal number to ASCII, just add 30. Very easy, right? What is not easy, what needs some work is, if you have a binary number, how can you get these decimal numbers? 255. Okay, that's what I'm going to explain now. So this is the last topic. I'm going to explain it now, okay? Okay. So let's start with the first problem. Okay, you have a binary number. Okay, let me use red color. Okay, you have a binary number, guys. So here, this number in binary. I'm assuming this number in binary. Okay, for example, 1111. Okay, 111. It's just a binary number here. Okay, so the question is that if you have a number like this one in binary, is that okay, guys? This number in binary should be 1,000 to 12,345. Is that okay? So the question is that, what should I do if you have a binary number like this one? What should I do in order to get 1, 2, 3, 4, 5? You understand what I'm saying? So this number in binary, I have to do some operation or I have to do conversion so that I get these numbers. 1, 2, 3, 4, 5. And then I'm going to take this number at 30 to convert to ASCII and send to the LCD, right? So here at 30 plus 30 and send to LCD and so on. Is that okay? How this can be done? How can we do that? Okay. Sorry, the mouse is not working well today. Okay. The way, look how it works, guys. It's very interesting. Look here. The way we have to do it, you have to divide by 10. Okay, so it has to be repeated division by 10. I'm gonna tell you how. Okay, if you look at this number here, guys, again, this number is gonna be in binary, but I write in decimal so that we can understand what this number is. Okay, so it's gonna be this number in binary. Okay, so I'm gonna divide this number by 10. Look what's gonna happen when I divide this number in 10. This is the quotient I'm gonna get, and this is the remainder. So the remainder is gonna be 1 digit. So when I divide by 10, I got 1 digit. You understand what I'm saying? And then I'm going to take the quotient divided by 10 again. So this is a new quotient, and this is the remainder. Great. So every time you divide by 10, you are going to get one digit, 1 by 1. And then I'm going to get the quotient again divided by 10, right? So this is the quotient, and then I'm going to get 1 digit, okay? After I divide it by 10 again, I'm going to get here, this is the quotient, and this is 1 remainder, okay? And then I'm gonna just divide this one, I'm gonna divide it by 10, the quotient is 0, and then I'm gonna get a remainder here. Once the quotient is 0, I'm gonna stop division. I'm not gonna divide it again, okay, guys? So every time you divide by 10, you are gonna get 1 digit. But look here, look at the order. So I'm gonna get digit from right to left, okay? So the last one here is the most significant digit. You understand what I'm saying, guys? Any question about the idea here? So if you have a binary number like 1, 1, 1, 1, 1, 1, 1, okay, guys? I'm gonna divide it by 10. This number is 255. I'm gonna divide by 10. When you divide by 10, you are gonna get 25 in binary, okay? Quotient, and then you are gonna get number 5. So I got the first digit, okay? Then I'm gonna get 25 divided by 10. When I divide by 10, I'm gonna get 5, and then I'm gonna get 2, and that's what I need to do. This is the purpose of all this conversion. The purpose of all this conversion is, given a binary number, how can you get the digit, right? So given, this is the purpose of this everything here. Given, if I give you 1, 1, 1, 1, 1, 1, 1, 1, okay, this is the input of decimal to binary. The output here I have to get number 2. I have to get number 5, number 5. That's it. This is decimal and binary. Okay. Any question here, guys, about the idea when you divide by 10? Okay, guys. So here's the remainder. Once the quotient is 0, I have to stop division. I'm done. Okay. So now I give you here a program. How can we do that? A very simple program. I'm gonna explain it quickly. Look here, guys. Here, write a program to convert a 16-bit number stored in register D. So I have 16-bit number stored in register D. Okay. So that means this one can have up to 5 digits, right? Because register D is 16-bit, so I can get up to 65, 535. So here, because it's 16-bit, I can get up to 5 digits. Okay. Anyway, so look as I exactly I said, guys. So look how I made it. Okay, the way I made it, as you see here, exactly as I said. I'm gonna put 10 in X. Okay, and then I'm gonna divide. Because this one is going to divide D, which has a number, by 10. You are going to divide it by 10, okay? And now the quotient has to go to X, and the remainder has to go to D. Is that okay, guys? Now I'm interested in the remainder, because the first digit the first digit from right to left is going to be in the remainder, okay? But actually, I want to tell you something here. The remainder has to go to D, but actually, D is actually, as we said before, D is B and A. But actually, your remainder here in B. So you don't need to worry about A. Just your remainder is in B, okay? Why? Because as I said before, when you divide by 10, the maximum number you can get 9. So you can get a number from 0 to 9. Is that okay? And 0 to 9 should be enough to be in a byte. So always your remainder also always in a byte, okay? And then here what I'm doing in this program, I asked you to store the decimal number in this memory location. So what I did here, guys, I stored B. As I said, I'm only need B, okay? Register B, I store it in this memory location, okay? So now I am done with the first division. This is the very first division, okay? Now I'm gonna exchange X because now my quotient is in X. Now I have to move the quotient to D for the next division, because in next division here, so here's I'm gonna take this quotient here, I'm gonna put it in D, so that next time I divide it by 10 again. Okay, guys. So this part, just to repeat again, but I have to work in this quotient. I'm gonna take this quotient, divide it by 10 again. Okay, guys. Yeah. Also the same thing here. You have to divide by 10 and then divide by 10. Okay. Here. Okay. One more thing I want to say here, guys, is here in assembly, the division is gonna give you quotient and the remainder. Okay, but in C language, if you want to do the same thing in C language, how can you get the remainder and how can you get the quotient? The remainder, the way you should get the remainder is percent. Is that okay? So for example, if you say any number, for example, 5% 2, this should be equal 1 because this gives you the remainder, percent. So percent should give you the remainder. Okay, what about the quotient? How I can get the quotient? The way you can get the quotient just by division. For example, 5 divided by 2, but you have to store the result in integer, right? You know 5 divided by 2 is 5 divided by 2 should be 2.5, okay? But if you store this one in integer, you are gonna get only 2, which is a quotient, okay? So what I'm saying, if you wanna do the same thing in C language, you have to use percent to get the remainder, and you have to use this division, but you have to store the result in integer so that you store the quotient, okay? Now, so this is the main idea. So the main idea, guys, you can just keep dividing by 10 until you get the digits, the decimal numbers. Once you get the decimal numbers, it's easy to convert them. It's easy to convert them to ASCII, and then after ASCII, you can use the ASCII. You can send them to the LCD. Okay. Now I'm gonna teach an easier way. So this is the technique. This is how it works, okay? But I'm going to teach another way. Another way is using functions. So we have here a number of functions. We can use these functions, okay? That's what I'm going to explain now, okay? So here we have a function, as you see here, guys. Again, if you want to convert this way by dividing by 10, it's okay. If you want to use function, it is also okay. So now I'm going to explain what functions we have. We have two functions here, guys, in C language. One function is called write integer to LCD. We have another one is called write long to LCD. Is that okay? Tell me what this function is doing, okay? All what you have to do, guys, for this function, you have to send the number here. A binary number, okay? So you have to send a number here, okay? And then this function is gonna get the decimal numbers. So it's gonna divide by 10 until it gets the decimal number, the digits, okay? And then it's gonna convert it to ASCII by adding 30, and then it's gonna display them on the LCD. Very interesting. So this function almost is doing everything. So any number you send here, number one, this function is going to convert this number to decimal, okay, a digit. Number two is going to convert the digits to ASCII, and then it's going to display them on the LCD, everything in one function, okay? So we have two functions, one for integer and one for long. What is the difference between integer and long? As you see here, guys, here I'm defining a variable integer. Here I'm defining a variable long. Integer can be 16-bit. Long is bigger. It can store bigger number, 32 bits. Okay, guys, any questions? So it's a summary in C language. Okay, you can use this function, okay, to convert the binary to ASCII and display it in the LCD, everything in one step. Or if you want, you can get the decimal by dividing by 10 and then add 30, okay, and then you can send to the LCD, okay. Same thing here for now I'm gonna move to the next part. How can you convert decimal number to binary? Okay, so that means if you have here, I have number 2, I have number 5, I have number 5. This is what we call decimal. Okay, guys. So maybe they are ASCII for if it is 32, 35, 35. Again, if you convert from ASCII to decimals, it's very easy. You just subtract 30. That's the easy part. So the key bit is going to give you 32. You subtract 30, you get 2. 35, you subtract 30, you get 5. 35, you subtract 30, you get 5. So now what you have 2, 5, 5. So now given 2, 5, 5, so I have to run algorithm so that I'm going to get 1, 1, 1, 1, 1, 1, 1, 1, which is 255, binary number. Is that okay, guys? Okay. How can we do that? What is the way we can do it? Okay. I'm going to teach 2 ways. Okay. And this is very easy thing. Okay. Look here, guys. The first, this 2, it's actually, we have number 2, we have number 5, number 5. Is that okay? That's what we have. This 2 it is in the hundreds, right? It is in hundreds. This one, it is in tens. This one in ones. You understand what I'm saying? So I can make equation. This is how I can convert. I can make a simple equation. I can multiply this one by 100. I can multiply this one by 10. I can multiply this one by 1, and then I add them together. That's true. Okay. In second grade, third grade, they teach students if you have like digits like this one, how can you make a number? That's exactly what we're doing now. Okay. So you can multiply everyone by its weight, hundreds, 10, and the 1, and add them together. For sure, you can do that. Okay. This is another way. This is one way. There is another way. Okay. What is the other way? Okay. I can make like a running conversion. Okay, running binary number. I'm gonna tell you what I mean by running. So every time I get a digit from the user, I'm gonna make a running. So I'm gonna tell you how. So this is one way. I'm gonna explain another way. Okay. Give me 1 second. I think the mouse is not working well. Yeah. Okay. Okay, now. Okay, guys. So what I'm saying, guys, I want to make like a running conversion. I'm going to tell you what I mean, okay? So, for example, you ask it the key bit to give you a number. This is the key bit. Okay? You ask it the key bit to give you a number. The key bit give me, first time, give me 32. Is that okay, guys? Okay. So what I'm going to do first, I'm going to subtract 30, as I told you, to convert from ASCII to a number. So now I got 2. Okay, and this is what I'm gonna do. I'm gonna say running decimal number. Is that okay, guys? So now you give me 32, and now the decimal number is 2, right? Now the user is gonna give me another number, for example 37. For example, okay. So what I'm gonna do, number 1, I'm gonna convert to 30. So now the number should be 7. This is the number I got. Okay. So how I can make the running decimal? So now I have 2 and I have 7. So what I'm gonna do, I'm gonna get the old value, this one. I'm gonna multiply it by 10. So now it's 20, and then I'm gonna add the new number here, 7. So now I got 27, which is exactly true. You give me 2 and you give me 7. Running. Okay, you got what I'm saying? You actually, when you multiply by 10, it's like you shift. So now you actually, this 2, when I multiply by 10, this 2 was in the ones. And when I multiplied by 10, I moved it to the tens. And this 7 is gonna come in the ones. Let me give you another example. So now, after that, you give me, for example, 31 this way. So I'm gonna subtract the 30, and now I have number 1. Is that okay? So now I'm gonna take the old one, I'm gonna multiply it by 10. So it's now 270. When I multiply by 10, actually, now I moved to 2 from tens to hundreds. I moved to 7 from ones to tens, and now I'm gonna add the 1. So it's 271. Is that clear? The idea is clear, guys? So this is another way I can do something like running decimal. Okay. So I'm gonna ask the user, give me a number, and when you finish, hit escape. For example, hit a certain key. Okay. Every time I receive a number from the user, I can make like a running binary sorry, this is a binary number, okay? So here you convert decimal to binary, but I'm gonna make it binary. So the first digit I'm gonna get is gonna be the same one, it's here. After that, every time I get one digit, I'm gonna multiply the old one by 10, and then I add this one. This is the technique I have to use. It's gonna work for any number of digits. Any questions? Yeah, I have a program here. This program is doing exactly what I'm explaining now. Yeah. So here, that's exactly what I'm explaining, guys. First, I got a number. This number, I call it in, I want to use a red number, red color. So here, yeah, here I'm gonna get a number in the very beginning from the user, and then once the user give me a second number, I'm gonna multiply by 10 and add the new number. Is that okay? Once the user give me another number, I'm gonna multiply what I have here by 10 and add the new number, and so on. So every time I get a new number, I can multiply by 10 and add. That's exactly what I'm explaining here, guys. Okay. So here I got one number here. I'm gonna get one number. I'm gonna multiply it by 10. Okay, and then this is the result is here. And then when I get a new number, I have to add it. This is the running. So here in this memory location, 2000, 2001, this is the running decimal. Okay. So here I multiply this one by 10, and then I'm gonna add the new number. I'm gonna keep doing that. Okay. So every time I get one number, I multiply it. I multiply the running, as you see here. I'm gonna multiply the running. Here, sorry, I'm gonna multiply the running binary number by 10, and then I add the new number. Okay, it's explained here. Okay, so this is the way you can do it. Or okay, so let me summarize what I said here, guys, before I give you functions, because always we also have some functions. So the way I told you guys what I'm explaining here, how can you convert a decimal to binary? If you have number 2, 5, and 5, how can you make 255, which is 1111111? How can you make something like that? Okay, I told you there are two ways. One way, if you already have all the digits of this number, so one way you can multiply this one by 100, because this is the weight of this number, multiplied by 10, multiply by 1. Actually, you don't need to multiply by 1, but I say multiply by 1 because this is in ones, but you don't know, because multiply by 1, you're going to get the same number. And then I'm going to add everything together. By this way, I can make 255. This is one way. The other way is, once you get a number, for example, I got number 2, so this is my number. I already converted to binary. Okay. Once the user give you 5, so I'm going to multiply this one by 10 and add 5 to get 25. So now I got 25. Okay. Now the user give you another number. I'm going to multiply this by 10, and then I add the new number. By this way, I can get 255. Okay. This is the way you have to do some operation like this one. So you have to do some mathematical operation. There is another way. What is the other way? We have some subroutines. I'm going to explain these subroutines in both in C and in assembly, and you can just use these subroutines just to make our life easier. Okay. So let's see what subroutines we have here. The first subroutines we have here subroutines to convert. This is in assembly. Okay. In assembly, we have subroutines to convert decimal to binary. Okay, and this is all the subroutines we have. Okay, so the decimal number should be stored in ASCII code in an array. This array should end with 0. For example, it has to be like, 32, and 35. It has to be an array. And at the very end, I have to put 0. Is that okay? So this is how it should be your number. Okay, and this the first location you have to store the first location in register Y, and then you call the function. That's it. So number one, your number. If you want to use one of these functions, okay, all what you have to do, very easy. Okay, your number, your digits, the decimal digits should be in ASCII, and you have to store them in an array this way, and you have to end the array with 0. Is that okay? And then all what you have to do, the beginning address, put it in register Y, and then call one of these functions. I'm going to tell you why you have 4 functions. And then you call this function. This function is going to convert this number from decimal to binary and store the result in register B if it is 8-bit, because we have here, if you look here, guys, we have these 2 functions for 8 bits. If your number is stored in 8 bits, okay? If you have a bigger number in 16 bits, so you have to use one of these 2 functions, okay? So what I'm saying, the input, what you have to send is to this function, it has to be array like this one. You have to put the beginning address in register Y before you call this function. This function is going to convert this number, okay, make it binary, and in case of 8 bits, it's going to be stored in register B. In case of 16-bit, it's going to be stored in register G. Okay, so I'm going to give you example now how can you use this function, but this function is going to make everything easy. You just store it you just call this function. This function is going to do the conversion. Okay, so as I told you, we have 2 types of this function. One is 8 bits. If your number is in 8 bits, as you know, guys, that means your number is up to 255. Okay, in case you have a bigger number, okay, so or you want to store the number in 16 bits, that means you can have numbers up to 65, 535. Is that okay? So in this case, you store it in, you can use one of these 2 functions. Okay, okay, so why we have two functions? Because one is for signed conversion and this is for unsigned. So this one is for signed and this one for unsigned. And in case of signed, if it is signed, in case your number is negative, so the first ASCII here should be minus. Okay, the ASCII of minus. Again, if your number is negative, for example, negative 25, so the way you have to do it is, here the ASCII of negative, the ASCII of 2, which is 32, the ASCII of 5, 35, and 0. And then you have your beginning address should be in Y, and then call this function sign. So this is gonna make sign to conversion. Is that okay? So just I want to make it easy. We have 4 functions. You can use this 4 function to convert the decimal to binary. Okay. Now I'm gonna talk about binary. We also have another 4 function to convert binary to decimal. Okay. This is what I have just explained now, binary to decimal. Binary means, remember, if you have 1, 1, 1, 1, 1, something like that, and from 1, 1, 1, I want to get 2, 5, 5. And it's better to get them even in ASCII, not numbers. Okay, but this is easy conversion from number to ASCII to number. This is easy. You add 30 or subtract 30. This is the easy part. But anyway, it's better to get them, because usually you are gonna do the conversion. You are gonna do this conversion so that you wanna display this number on the LCD. So that is why it's better to have this number in ASCII. Is that okay? So, and this is what this function is doing. Very easy. So what this function is doing, guys, I'm going to explain now what these functions are doing, okay? This function, number one, again, we have 8 bits, similar to what I have just explained. We have 16 bits. We have signed and unsigned, signed and unsigned. Is that okay? Number two, where is your binary number? The binary number, in case of 8 bits, you have to store it in register B. In case of 16-bit, you have to put it in register D. So before you call the function, you have to put your number in B or you have to put it in D before you call the function. Is that okay? This is number one. Number two, what this function is going to do, this function is going to do the opposite of this function. Listen to me. This function, I have to give it array with the ASCII, and then it's going to give me a binary number, 255. The other function is going to do the opposite. So I have to give it 255, and then it's going to give me array. That's exactly how it works here. Okay. So for example, I can say, I can put in B, for example, 255. Okay. Sorry. Excuse me. Sorry. So here I'm going to put in B 255, and then I'm going to call the function. What this function is going to do is going to give me 32, 32, 35, and 0. Starting from location, from array, starting from location pointed by Y. You got what I'm saying? So before I call this function, I have to do two things, not one thing. Number one, you have to put in register B the number you want to convert. For example, 255, put it in B. This is number one. Number two, you have to put in Y the location where you want to store your array. So you have to initialize Y, because this function is gonna store the number starting from Y. Any question, guys? Okay, now look at the very interesting thing. If you remember what I taught last time, put string LCD. You remember how put string LCD worked last time? Put string LCD, the way it worked, it needs a function like this one. You can send it to put string LCD to display on the LCD. Okay, guys? What do you mean exactly? What I mean is, and this is a very interesting thing, if you have a binary number, you can call this function. This function is going to give you array. And then you can take this array, send it to put string LCD to display on the LCD. Because the way I made these functions is just I made them compatible. Compatible means the output of this one, it can be input to this one. And that's what I'm going to show you now in the next program right now. Any question, guys? So what I'm saying, we have some subroutines. These subroutines can convert binary to decimal, decimal to binary. Okay, you can just use them. This is in case of assembly. Also in C language, we have some subroutines. I'm gonna explain them. Okay, but before I show you next program, I wanna tell you here about one function, one new function. You can just use this function. Is like delay YMAs. So in exams, in exams, we don't have more quizzes. So in exams, you can just use the function. You don't need to give me the content of this function. It's a very interesting function. Okay. So I'm going to tell you what this function is doing. Okay. Very useful. So we have a function called getKey. Okay. Okay. We have a function I explained to you before. It's called keypad. Do you remember keypad? When you call keypad, that's what we're gonna do in the coming lab, this week lab. When you call keypad, you are gonna get ASCII from the user, for example, 32, 37, ASCII of the digits the user hit. Okay, so keypad is gonna give you only one number. Is that okay? What if the user wanna give you like 337? So multi-digit number. Right? So the way you have to do it, you have to use keypad multiple times. So because first time you use keypad, you are going to get one digit, next time one digit, next time one digit. That's true. Is that okay? That's exactly what get number is going to do. So get number is going to call keypad multiple times. Okay? And then, so again, what is the difference between keypad and get number? Keypad is going to give you only one digit. What if you need to get a number from the user? 372, 2321 number, like multiple digits. Okay, so how can we do that? Git key is gonna do that. Okay, so git key, inside the git key, we're gonna call key bet multiple times, as you will see now. So look what I'm writing here, guys. Get number subroutine is gonna get multi-digit number from the user and to store the ASCII of this number in array starting from location pointed by Y. Is that okay? And then it's gonna put 0 at the end. Okay, it's gonna continue taking number from the user until the user hit bound key. So you got what I'm saying? So the user, for example, if the user wanna enter 3, so it has to hit 3, and then 3, and then 7. Now I am done. So I'm gonna hit bound. So once you hit bound means you are done. So your number is 337. So what this function is gonna do, this function is gonna keep taking number from the user until the user hit bound. Okay, and then this function is gonna put it in array in ASCII 33, 37, and it's gonna put 0 at the end to tell you this is the end. Where this array is gonna be stored, starting from location pointed by Y. That means before you call this function, you have to set Y. You have to tell the function where you want to store this one. Okay. Another important thing, guys, you can see this one is compatible. The output of this function is compatible with put string LCD. That means that's what I'm gonna do in the coming program. That means you can call this function. This function is gonna take a number, multi-digit number from the user in this format, and then you can take this one and think to put a string LCD to display on the LCD. So you can take the output of get number, send to put a string LCD to display it on the LCD. Not only that, you can take this one and you can use one of this function here, okay, to convert it to a number, and that's what to binary numbers. That's what I'm gonna do right now. Okay, so. Okay, guys. So I'm gonna quickly explain this function, but just you can just use it. Okay. So this function, as you see here, guys, I'm gonna call keypad. Okay. When you call keypad, there are two. I'm gonna check if it is asterisk. If you hit asterisk here means it's a minus. So for example, minus 37, something like that. So if it is minus, okay. If it is this is true, I'm gonna go to negative. In negative, I'm gonna put the ASCII of minus. I'm gonna put in the array, right? If it is not asterisk, I'm gonna check if it is bound. If it is bound means I'm done. I am done, because always this is the last digit after you finish entering your number. The last key you have to hit is bound. So if it is bound, I'm gonna come to here. I am done, and then I'm gonna put 0 at the very end. I'm gonna put 0 and then return. Is that okay? And now if it is not. So if it is not this one, so it means it is. I'm here. I'm gonna check if it is a correct number or not. So I'm gonna compare with 30. If it is below 30, if you under, I have to make sure the number is correct. So it has to be something between 30 and 39, right? Okay, because maybe you hit A, maybe you hit B, something which is not a number. Okay, so I have to check if the ASCII you entered less than 30, that means it's wrong. Right? If it is more than 39, it means it's wrong. Okay, so that's what I'm doing here. So it is blue. If it is below 30, so I'm not gonna store it in the array. I'm gonna come back to take another number. So this number is not valid. I'm not gonna store it in the array. Now I'm gonna check with 39. If it is more than 39 again, so this number is not correct. So it's not between 0 and 9. I'm not gonna put it in the array. Okay. If this number is greater than or equal 30, less than or equal 39, so I'm gonna store it in the array here. Once I store in the array, I'm gonna come back to here again. Okay. Again, as I said before, guys, I'm teaching all functions, but for exams, all what I need from you is how can you use these functions. Any question, guys? So I have here one program. You will find in this program I'm gonna use. Look here, and this is the most important, interesting thing here, guys. You will see. I'm going to use both string LCD. Also, I'm going to use decimal to binary converter, right? also I'm going to use get number, right? So the good thing, as I said, these functions are compatible. So the output of this function is going to be array ASCII, 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 and at the int 0. You can take this one and send it this one, because this is the input. This is the same format this function is expecting. Okay, you can take this one and send this one so that you can convert it to binary. Okay, so what I'm doing here in this program, guys, I want to take two numbers from the user, I want to add them together. So I want to take, for example, the user can give me 21 and then 11. So this is what user give me. I want to get two numbers from the user, and then I'm going to display these two numbers for sure, but also I want to add these two numbers together. So I have 30, you just add 33, sorry, 32. You just add two numbers, okay? So the way it's going to be done, guys, number one, I'm going to use get number, the one I have just explained right now, to get 21, okay? And then then after I get this one, I'm gonna use put string LCD to display this number on the LCD, and then I have to convert this number to binary, okay? And then I have to repeat again with the second one. Now I have a binary number and binary number. I have to add them together. Now I got the summation in binary. And then once I have a binary, I have to convert it to ASCII, like 33. 32, and then I have to call again both string LC to display this result. Okay, so let me go through it. So number one here, guys, I have array here. This is the array. So now I'm gonna call get number. But before I call get number, I have to tell where you wanna store the number you are gonna get from the user. So here I wanna store it starting from location Y. The location pointed by Y, which is here. So what this one is going to do, this function is going to get a number from the user, it's going to store it in ASCII here, and the end is going to give you 0. Okay, here this part you just clear screen, clear LCD, and move the cursor to the right. That's it. And then this is a good thing. Look what I'm going to do here, guys. I'm going to take so this one already got a number. It's going to put here in this array. I'm going to take this array. And then I'm going to send it to put string LCD, right? Just to display it in the, this is again because they are compatible, okay? So put string LCD, okay? And now after that, I'm going to take the same array, and now I have to convert it to binary, okay? Because in order to do addition, I should have two binary numbers, okay? So here, after I convert it to binary, as I said before, it's gonna store it in register B, okay? And then I'm gonna store it in what we call number. So now I got the first number, okay? I'm gonna repeat the same steps again. In order to get the second number. So here, guys, here I'm gonna get the second number. Here I'm gonna display the second number, okay? Here I'm gonna write equal, okay? Now the second number, I have to convert the second number to binary. Now I have two binary number. Remember, one binary number I store it in location called to number. This is the one I got at the beginning. Now I got another one in register B. So now I have two numbers in binary. I got two numbers from the user in ASCII. I converted them to binary. Now I have two numbers, so I can add them together. And now I have the summation in binary. Okay, so I have to convert this binary to ASCII so that I can display it on the LCD. That's exactly what I did here. So here, I'm gonna call this one. This one is gonna convert the binary number in register B, and it's gonna store it in this location, starting from this location. Okay. So this function now is gonna give me the result. For example, 32, and then 0. And then I'm gonna take this one. I'm gonna send it to put a string LCD to display the result. Okay. Any question, guys? Okay, now the last thing I'm going to teach here, guys, this is the last thing in this chapter. The last thing I'm going to teach is now in C language. We also have here a couple of function in C language. So here in C language, I already taught this one, guys, write integer to LCD. So here, this one you have to put here number, binary number. Okay, and then it is gonna convert it to decimal and then to ASCII and then display the LCD here and here. Okay, the new one, this is the new one here. we have a function. This function called a number. Okay, this function you have to send here a pointer to an array. So you have to make an array. For example, this array should have the ASCII of the number you want to convert to binary. Okay, for example, 32, sorry, 35. This is an array. Okay, for example, so this array, send it here. This one is going to give you a number in binary 255, which is 1111111. That's what I want to say. Okay, so you have here, so here you have to have array like this one. Okay, and then I'm going to show you how now quickly. So here, so this is the array I told you about it. This array should have the ASCII. Okay, and this is a pointer. This is a pointer here I'm going to use. Okay, and then here. And then here, this is how in this program I want to get to one number, and then I double it, and then press. After I double the number, I'm gonna convert it to display it. Okay. So here, get key. Again, you remember get key is gonna give you only one number, like keypad. It's like keypad. Okay. And then I'm gonna get this one converted to ASCII. So this key, because get key is not gonna give you ASCII. Keypad is gonna give you ASCII. Get key doesn't give you ASCII, give you number. Okay, this number you have to convert it to ASCII, and then this number I'm gonna put it here in this array. So now what I'm doing here, I'm gonna make array. I'm gonna take number from the user like 32, 35, 35, and so on. Okay, in ASCII. Okay, and then once the user hit this one, okay, which is asterisk, that means I'm done. I finished entering the number. So what's happening here, guys? Every time I come here, if you enter a number, I'm gonna store it in array. So this part is gonna do that. Every time you enter a number, I'm gonna store it here in this array. I'm gonna store here in this array because here I get a number, and now if this number is less than 10, it means a number from 0 to 9. If not, so I will see if it is asterisk. Okay. Again, asterisk means you are done, you finished. Okay. So anyway, so here every time you give me a number, I'm gonna store it in array. Okay. So once you store it in array, okay. Now look what I'm gonna do. Look here, guys. So here I'm gonna send this array to a function called to number. That's what I explained right now. PTR is a pointer. When I sent array, I actually sent a pointer. I defined as a pointer here, guys, and then I said PTR equal buff, and buff is the name of the array. Okay, so here I'm not gonna send it. I don't send the array itself. I send the beginning address, which is a pointer. Okay, anyway, so this function is gonna take this array and then it's gonna convert it to decimal number or binary number. Okay, and then this binary number. So this number, the binary number, I'm gonna multiply it by 2. So here, this part here, guys, this part is doing conversion from decimal to binary. Okay. So now I have the number in binary. Okay. Now I'm gonna multiply the number by 2. Because this is the purpose of this program. I wanna double the number. Now I have the solution. But it is in binary. So I have to convert it to decimal and display it. That's why look here. Look what I did here. So I got here this number from here, guys, and I sent to this one. Right long LCD. This is very interesting function because this function is doing a lot of things. Just one function. This function number 1 is going to take the binary number, is going to convert to decimal. This number 1. Number 2 is going to convert the decimal to ASCII. Number 3 is going to display it on the LCD. Okay, guys. Anyway, I think this is the end of this chapter. Any question here, guys? So here, what I did today, guys, I explain number one. Why we need to convert the binary to decimal and decimal to binary, okay, and what this means and why we need it. Okay. Number 2, I explain the main idea. The main idea, as I said, you can divide by 10, or you can multiply by 10. As I said, every time you get one number, multiply by 10 and add a new number. This is main idea. You can do it. Okay. Also, on top of that, I explain we have a number of functions. We have a number of functions that this function can just do this conversion, right? Just to make programming easier. Okay, you can just use this function. Any question, guys, here? Okay, so Wednesday, well, as I told you, we're going to have test 2. It shouldn't take more. It's going to be a small test. It shouldn't take more than one hour. So it's going to focus on chapter 3. Okay. Now we still have time, so I'm going to move to chapter 4.
Is this test going to be like small little parts like it was for test 1, or is it going to be like the last
it's gonna
homework where it's going to be?
No, it's going to be a program. For example, I'm going to tell you application. For example, I'm going to tell you a switch. You have to read a switch. You got what I'm saying? And once you read the switch, if the switch is 1, you have to turn the light on or something like that. Okay, so it's going to be application. It's not going to be like small pieces. Oops. You got what I'm saying?
As the home taking.
Yeah, it's going to be in the first 1 hour in the lab. So it's going to be during the lab anyway. Okay. Sorry, the keypad is not working.
So is it just like one question then?
Yeah, it's going to be one question. So the way you have to prepare it for it is, I already taught how can you use how. Just sorry. I taught how can you use LCD, right? Or I taught how can you use the 7 segment, for example. Okay, maybe there is one part about the 7 segment. Okay, maybe we have another part about the switch. Okay, so it's going to be mainly about the devices I taught in this chapter. Okay. I'm sorry, it's not working. So as we always do, so the exam is going to be open book as well. Okay, so it shouldn't be difficult if you understand what I taught here in this chapter. It shouldn't be difficult at all. Okay, so anyway, so let me tell you what this chapter is about. This chapter is about something called interrupts. Okay, so let me explain what I mean, what we mean by interrupts. Okay. So the first part here in this chapter, I'm going to explain what the concept, the idea, what you mean by interrupts. This is number 1. Number 2, I'm going to explain how can you program interrupts. Okay. Number 3, I'm going to talk about 2 types of interrupts we have on the board, IRQ and what we call RTI. Okay. So let me tell you first what is the definition of interrupts and why they are good, why they are very good, why we need them. I'm going to explain all of that. Okay, guys? So let me look at the definition here. An interrupt is an event that requests CPU to suspend the program execution briefly and run a subroutine. And this subroutine is called interrupt service subroutine. This is the definition. So what did you understand from this? What did you understand from this definition? You can understand interrupt means we need event. I'm going to give you more details what you mean by event, but for now, there should be an event. And because of this event, CPU has to suspend the program. And this is to go execute a subroutine. This subroutine is called interrupt service routine, right? Okay, guys? So number 1, there is hardware event. When the event happens, as you see here, look at the picture here, guys. After we execute this instruction, we have to move to this instruction. After we execute this instruction, we have to move this one. That's what I told you, right? This is not very accurate, by the way. Let me say it again. After we execute this instruction, we move to here. After we execute this one, we move to here. This is not very accurate, actually. Okay? So what is accurate? What is accurate is, after we execute this instruction, if there is interrupt, okay, CPU is gonna suspend the program, go execute a subroutine, and then it's gonna come back to here. If there is no interrupt, right? So after you execute one instruction, you are gonna move to the next instruction. So what I said is true, but there is a condition. So after you execute one instruction, microprocessor is gonna move to the next one if there is no interrupt, right? Then it's gonna move from here to here if there is no interrupt. Move from here to here if there is no interrupt. If there is interrupt, after you execute this instruction, not during, after. So that's exactly what happens. What exactly happens, guys? After executing every instruction, the hardware should ask the CPU to execute next instruction, or to execute a subroutine, right? And come back. So you are telling me a subroutine. So it is like you are calling a subroutine. That's true. It is like you call a subroutine. But I taught you before, in order to call a subroutine, you have to use a command to call the subroutine. Do you remember branch or jump subroutine? Yes. Here, you execute a subroutine, but you don't write a command to call the subroutine, because who's gonna call the subroutine is the event. You got what I'm saying? So if you look here, don't be confused. If you understand what I'm saying, you should be okay. What I'm saying is, if you look to the instruction here, guys, I don't write here one instruction to call a subroutine. That's true, because interrupt, it overlaps with subroutines, but it's not exactly the same thing, right? Where is the overlap? The overlap is in interrupts, you have to leave the program, go execute something, and come back. This is the overlap. This is the same thing we do when you call a subroutine. Okay, what is the difference? The difference is, in case of a subroutine, you have to call the subroutine. You have to write instruction to call it. Here, I'm not gonna write instruction to call it. Okay, who's gonna call it? Event. When event comes, because this event is not gonna come all the time. So when event comes, the hardware is gonna direct the CPU to go execute a subroutine and come back. Any questions about the concept? For sure, don't ask me what is event. I'm gonna give you more details. Okay, guys. So let me summarize what I said. What I said is, after executing any instruction, this instruction, it can be in the main program, or it can be in a subroutine. It can be in a subroutine. So that means you can go to interrupt from a subroutine. It doesn't matter, right? This is what we call a program. So now that's what you should understand. Now what I'm saying is that you have a program. What I'm saying is the following, guys. Number one, you have a program, and you have interrupt subroutines. We call them interrupt service, ISR. Interrupt service subroutine. This is how your program is gonna look like now. Okay, this is the new part we are gonna add, right? So now your program, this is the program itself, and inside the program we have the main function or the main, and you have a subroutines. All of this we call it the program. That's what we have done so far. What we have done so far is you have a program and you have functions. What we are gonna add to your program, what we call interrupt subroutine. What I'm saying, every interrupt is, we have several interrupt subroutines. I'm gonna teach them for sure. Every interrupt subroutine should be called by event. When the event, hardware event, I'm gonna for sure give you what I mean by event. When the event happens, when the hardware event happens, your program, your CPU is gonna suspend the program, go execute and come back. Okay, so that means you can leave a function. If you are in a function, you can leave a function to execute it and come back. Or if you are in the main, you can leave the main and come back. Any question, guys? So just in one sentence, interrupt subroutine is like calling a subroutine. You leave the program, execute something, function, and come back. Okay, so here that is the interrupt, but you don't write instruction, because the way you are gonna call, you don't write instruction to call it. The way you are gonna call it, guys, is by event, hardware event. Okay, so here I give you example here, guys. Okay, there is like a train is coming. I have a sensor here. Okay, when the trend comes, this sensor is gonna generate like as you see here, like a pulse. This pulse is gonna input this to. This is what we call event in this case. So this is an event. Okay. So this pulse, when this pulse comes, it's gonna go to the hardware, and when go to the hardware, it's gonna request interrupt. It's gonna request interrupt. Okay. And then if we serve, this is the expression we use. We use the expression request, you request interrupt. And then when you request interrupt and I go execute the subroutine, interrupt subroutine of this interrupt, okay? So is we use the term serve the interrupt, okay? So so an event is gonna request the interrupt, and then when you execute the subroutine, we say we serve the interrupt, okay? So in this example, what I'm saying, guys, we have a sensor. This sensor is gonna, when the trend comes, is gonna generate a pulse. In this pulse, okay, your program is gonna go execute ISR, interrupt subroutine. Here in the interrupt subroutine, for sure, you have to write something related to the event, right? So there is event, and I have to respond to this event. To respond to this event, you have to write a code here in the interrupt subroutine to respond to this event. In this specific example, the way I have to respond to this event is by closing the gate. You have to close the gate. Okay, guys? Any questions? Anyway, it's a very important topic. It's not difficult. I think we have passed the difficult part in this course. Okay, so anyway, it's 2:50 now. Next time I'm gonna continue this topic. Okay, any questions?
Yeah, can we take the test 2 as a home test and the do lab on Wednesday?
No, the test is gonna be on Wednesday. It's gonna be in the first hour. It's going to be 1 hour test. It's going to be similar to test 2, 1 hour. It's going to be a program. I'm going to ask you to do some, to program application, and it's going to focus on chapter 3. Okay?
Wait, could you repeat what you just said? Did you just say we'd already taken test 2?
Oh my gosh.
Or did you mean test 1?
So
what I said is it is going to be like test 1. Right? So
oh, okay.
Like test 1, it's gonna be 1 hour, 1 hour test. Okay, I'm gonna give you a programming problem application. This application may use LEDs, it may use switches, it may use buzzer, everything I taught in chapter 3. You got what I'm saying? And then I ask you to program it in 1 hour. And then it's going to be similar to test 1. After you type the program, you are going to email it to us to grade and return it back to you, similar to test 1. Any other questions?
So you're not open to like making a take-home test or anything?
That's what I usually do every year. This year I'm gonna change the plan because what I used to do is I used to make this test like very big application, and I give the students like 1 week, and the students demo it. But now, because it's going to be difficult to demo, right? Because we are working from home, so I change it. What I usually do is going to be like test, like test 1 or like the final. Okay.
Okay.
If you, all what I need from you is in chapter 3, I taught how can you use devices, okay? If you understand how can you program these devices, similar to, nothing will be new. That's what I promise. I'm not gonna bring anything new, right? Anything like surprise or something I didn't teach. If you just understand what I taught in chapter 3, you should be okay. Okay, I already taught how can you use the switches. Okay, so if I give you in a problem, if the switch 1 is connected, you have to do this, you have to do that. Okay, or if you have a port, this port connected to a sensor, and you need to read this port, and then based on this value, you can turn the light on, turn the light off, and so on. You got what I'm saying?
So I have a question. Is the homework supposed to be due tomorrow, or did you mean to do that Wednesday? Because you said it's due tomorrow right now, as of right now.
I said in one email, guys, I'm considering the current crisis. So I'm okay if you. I'm very flexible about the deadlines. Okay, so if you wanna submit it later, I'm okay. Okay.
Yeah,
So
it's just a lot because we all have,
I'm
especially
okay.
with EM Fields and Circuits, we have a
I
lot of
think
stuff this
maybe
week. So.
I'm okay. Maybe you missed my email. I know this is difficult time for everybody. So what I said, guys, I'm flexible in the time about any deadline. Is that okay? So if you want to submit it by next week in the final week, I'm okay. But for sure, it has to be before. It has to be by the end of the final week. Okay. Is that okay?
Yeah, I think that's good.
Okay.
Thank you.
Okay, guys. Any other questions? Okay, thanks, guys. So see you. Bye.